when I set out to plan out this semester course, okay, and if you have your course outline there, it's not necessary, but if you have it there, I'm going to refer to it in a second. I literally thought out, okay, what are all the cool maths things that we just never get time to look at, or they're not really related very closely to the other parts of maths that you do, or it's very hard to write a test for certain things, and so if you can't assess it, you can't really do it as a topic, and that's not just maths, that's all your subjects, okay? So I laid out those 10 sort of topics and I said, look, these are really cool, I would love to do these, but the problem with doing that is that they're kind of all, they're all disconnected and random, right? And one of the best ways to confuse someone is just to give someone a bunch of random disconnected things that have no order or sequence to them. And it's just like, here you go, have fun, and I don't expect you to remember any of this, okay? So I've thought very long and hard about how to string these together in a way that makes sense, okay? So where do we begin? What was our first topic, do you remember? It was beauty and mathematics, right? The reason why I started there is because kind of the theme of this course is to think deeply about simple things, right? And I think the reason why this was a great place to start is because the things we looked at were both very, very familiar, right? They're things we've seen before, things like architecture and parts of the human body and all those kinds of things which we kind of use as a given. It was familiar, but it's also surprising. The kinds of things that we discovered, it was kind of like, oh, really? Right? There's more to these simple things than first meets the eye. That's why that was what we did. Now, secondly, after beauty mathematics, the last topic that we just finished was fractals. And the reason why is because I think fractals are one of the best examples of beautiful shapes that are generated mathematically but also occur, in nature, right? That's why they're familiar. We looked at rivers and ferns and galaxies and all those kinds of things which exhibit this, right? And I broke it off as a separate subtopic because you can spend a lot of time looking at it. Okay? Well done, that was pretty good. Now, that then leads us to the question of, well, where do you go from here? What do you think? You have a look at the topics that are laid out there, right? What do you think would be the next natural step? Okay? Now, I kind of think, when I think fractals, right? We drew some of these and it took a long time. When I think fractals, I think infinity. Right? I think of things that repeat on and on forever, right? That's the whole thing that makes a fractal, right? So I thought, okay, I'd really like to do the topic, which I think I've called it math error. What your calculator tells you when something's undefined, things like infinity, right? So infinity is what I wanted to get to. I think that's kind of a natural next step from fractals. Okay. However, the mathematics of infinities, plural, it needs some groundwork laid before we get to it. Okay. Here's kind of the illustration I would give. I think maths is a bit like tourism. It's about going and seeing cool, amazing things and learning how it all fits together and how it works and what's interesting. Okay. High school, you get 6 years, right, to go on a tour. And because it's only 6 years, you've got all these other things to learn, you only get to look at so many things, right? So what we're doing is we're going off the beaten track, looking at some places you would never discover otherwise. But just like in real life, in tourism, if you want to travel, to get around you need some language, right? If you want to go and look at these things, you need to learn new languages to be able to describe these things. The biggest, most important piece of language, there's lots of them, right? Each one has its own language. But the biggest one for infinities is our next topic, which is set theory. Okay? Now you're like, really? Yeah, really? Trust me, we're going to get there, okay?